Hi, everyone. We need to talk about artificial intelligence. The pace of AI has been increasing for the last several years, and there was a real turning point last week on Thursday where the company OpenAI released something called ChatGPT, which is just staggering. Essentially, it has provided like a chat interface with this massive language model called GPT 3.5, actually, which is just staggering. And it has a lot of implications for us as academics, as teachers, researchers. And so I think the easiest way for me to tell you about this is just to show you, is just to do a bit of a demonstration. And you can see for yourself what this means for us and the entire university system, really. So I'll talk about it from the perspective of teachers, students, researchers, and all of us, our home lives as well. So let's just go to the page. We'll go to chat.openai.com, and I encourage you to check it out yourself. So if you just go to the website, you can sign up. If you click sign up, you just need to create an account, which is quite easy to do. It's free, it's easy to do. And so I'll just log in here. And this is it. It's just a little bar. It's like a little chat interface, as you can see. So you can ask it things like, explain quantum computing in simple terms, or got any creative ideas for a 10-year-old's birthday? Or how do I make HTTP request in JavaScript? And it's really quite good. It does have some limitations that they acknowledge. May occasionally generate incorrect information. At the moment, they're working on that balance. It may occasionally produce harmful instructions or biased content, and it has limited knowledge of the world and events after 2001. Take all of that with a grain of salt. It's still bloody impressive. So let's see what it can do. As I said, the first thing we'll do is just start from the perspective of a teacher. So I'm teaching the third-year course in judgment decision making, again in semester 1, thinking about making some changes. So I can just type in, write a course syllabus for a third-year university course on judgment decision making. And it'll respond, here's the course description, course objectives, here's an outline, right? And it will list, 6 courses, the course requirements. I could say make it 12 weeks instead of 6. There we go. So we have the same thing, but we have each of the 12 weeks, and it'll break it down in terms of the content. Right, so weeks 9 to 12 are research projects and so on. So you could keep, if you click this little try again button, it'll keep doing it until you're satisfied with the results as well. And it generates each of these things from scratch every single time. So here we go, course objectives. Right, not bad. So this could be useful in figuring out the sort of content that I might want to include, but I might just want to drill down specifically. So here in week 2, we have just heuristics and biases. So I could say something like, give me some more ideas for the content and readings for week 2. Here we go. For week 2, we have these. Yeah. Some great papers. Here are some activities that you can do in week 2 as well. And you could even drill down even further. Well, why don't we go a little bit further and say, give me 3 multiple choice questions, each with 3 choices, labeling each one as correct or incorrect for week 2. And see what it does. There we go. Question on the availability heuristic, one on the representativeness heuristic, heuristics and biases approach more broadly. And so you can see the answers here. Correct for each. Sweet. So I could use that. I could generate as many as I'd like. For example, I could also generate some short answer questions. I want some short answer questions for week 2, along with a marking rubric as well. So I could give that to the tutors to be able to mark if I wanted some short answer questions. Here we go. Explain the availability heuristic and provide an example of how it can influence judgments and decisions. Here's the marking rubric. Discuss the role of cognitive biases in shaping judgments and decisions. And there's the rubric there. Great. Now let's look at it from the perspective of a student. I could say, I'm a student taking a 3rd year course on judgment decision making, and we're learning about these psychological and cognitive processes underlying heuristics and biases, such as the role of attention and memory in decision making. And I've read the following papers on the topic. And I could list the papers here: Kahneman, Tversky and Kahneman, Gigerenzer and Todd. Create a list of questions to help me study. Just like this. And so again, it knows, in fact, it knows everything on the internet. So pretty much it's trawled everything. It also has access to more than 175 million scientific papers. So it knows about these papers and books. It's been trained on all of them. And so it can generate a pretty decent list for us as well. So here's some questions. Those are all great. That might help you guide your studying. You could even have a practice test, say. How about some multiple choice questions? And so here it'll generate, some nice multiple choice questions for us. Great. I'm having trouble differentiating between, say, availability and representativeness. Can you explain how they differ? So you can use this as a pretty decent guide to help you figure out specifically, almost like a tutor, a tutor that's specific to where your weaknesses, where your gaps are as a student, and it can explain things to help you, the student, drill into the specific things that they might be unclear about. I might even ask for a few study questions to help me distinguish between these two concepts. Notice what I'm doing here. So you can actually, it has a persistent memory. So it knows everything that I've listed above. And I don't have to explain it from scratch every single time. I can just say these two concepts, and it knows what I'm talking about here. And it can shape the responses just like that. So this is all great. It's incredibly powerful for students, but like any powerful technique or tech like this, it comes with a dark side as well. And so I would imagine that the sort of capabilities here are pretty clear, but students can absolutely use this to cheat. They could just type in the question on the quiz and get an answer that is probably going to be quite correct and impressive. It can write entire essays. It can write an abstract. It could write an honors thesis if you gave it the information that you were looking for. So this is the sort of thing that we need to reckon with and figure out what we're going to do as far as reforming our assessment, or essentially how we do what we do more broadly. But that's just teaching. Let's look at it from the perspective of research as well. As I said, it's a large language model. And like any large language, it knows a lot about programming languages as well. So we can say, create a simulated data set that compares 50 chess experts to 50 novices, where we're testing their recognition memory performance. We want to use their we want to see whether there's a significant difference between the two groups, so give us their means and standard deviations. Also plot the mean for each group alongside the individual data points for each subject and include a statistical test. Do all of this in our markdown. Great. So here we go in our studio. Let's just do this. Here we go. So there's our first chunk where we're setting that information up. And then here, Oops. And there we go. That looks great. So we have the means for the two groups with the big dot in the middle representing the mean. We don't need to install that package. That's why it gave me that issue. So here we have that. Great. Now let's test for significance between the two. So we just conduct a t-test here, which looks like this. Great. Well, just two-sample t-test, and we can see the difference between the two. So we can get a little bit more adventurous here and just simply type, do it all again, but add a third group of trainees and conduct follow-up analyses as well. So it remembers everything that was in there, and so it'll just go back and revise all of this. So here we have this information. So we just pop this in here. So now we have the trainee scores. Great. And visualizing the data. So we'll just pop this in here. This time we won't install that package. Just like that. So now we have the three groups, and the trainees are the blue ones, and they're in the middle of those two, which is great because it knows what trainees are. Here we go. And now test for differences between them. So instead of a t-test, now we're going to run an ANOVA. There's our ANOVA table. And then we have follow-up tables. It didn't finish. Just say finish. Here we go. Boom. And so we have the Tukey that compares the differences between each of those groups. Just like that. So that's fantastic. So now if doing this in R Markdown isn't your thing, you could say, look, I only know how to program in MATLAB. Say, do it all again in MATLAB. And it'll say, no problem. It can do all of that. And that's the code for MATLAB. So let's just try it. We just take... Right, it's giving us a lot of comments for each step along the way, which is nice. A lot more than I use. All right, so it didn't finish that, but let's just have a look at what it did. So let's run it. There we go. So we have our three groups, experts, novices, and trainees, and it goes all the way through. And we could prompt it to finish up that follow-up analysis, but we won't bother. And finally, we have, for those of you who are still stuck using SPSS, do it in SPSS, and it will give you the same, the syntax in SPSS that you can run, which looks great, but I'm not going to run that because I don't use SPSS. So that's one way. Here's another one. So this is all really nice for a set of simulated data. I decided to take it one step further. And what I did was I told ChatGPT about an experiment that we actually ran. And it actually, in a few tests that I did, it suggested that it could tell me about patterns in my data and so on. And I was like, well, how do you know about the data? And it says, well, you can just input them into the model. Okay, well, let's try that. So here's what I've done. We do this. Oops. Let's scroll to the top so I can read it to you. In a series of experiments, Newman discovered that people were more likely to be fooled into believing false claims when they were presented with a richer media type. In these experiments, people rated trivia claims to be more true when they accompanied an image, regardless of their ground truth. Newman named this the truthiness effect, and we aim to replicate and extend this effect to see if it generalizes from photo to video stimuli. This was an honors project last year. Each of our 84 participants were tested on 30 claims, 10 text, 10 photo, 10 video, where 5 of these 10 claims were true and 5 were false. And they provided a rating from 1, sure, false, to 6, false, sure, true. The data are provided below. What can you tell me about the patterns and trends of the data, in the data, which might help me generate insights and provide some recommendations that can inform our future research? And here I just pasted the raw data, separated by a comma. So we have the subject number, the condition, whether it's text, video, or photo, whether the claim was true or false, the actual claim itself, which it doesn't really need to know about, and then the rating at the end, whether it was 1 to 6. So we have all of that in there. It's just quite massive. And we just click go. And there it is, all of that information. It's a very cool experiment, actually. There we go. And it says the data provided are from 84 participants on 30 claims presented in these different formats. From the data, it appears that participants rated claims to be more true when they were presented with richer media type, regardless of the ground truth. This replicates and extends the truthiness effect, where people were more likely to be fooled into believing the false claims. Additionally, the data shows that participants tended to rate claims as more true when they were presented in photo or video format compared to text. This suggests the truthiness effect may generalize. These effects would inform future research and so on. I could ask it, give me the means for each of these conditions. There we go. And you could do it in just like that. So it does it, where I'm actually reading in those things. Oh, there we go. It will produce the following means for each of these conditions, and it will show me those particular means, which is great. So again, this is pretty staggering what this thing is capable of. And that's research. Now let's look at home. These are some, those of us who are going to be spending a bit of time away from the university could ask it something like, what are some festive cocktails that I can make for this holiday season? Here we go. Here's some eggnog, and it gives you the recipe for eggnog, mulled wine, peppermint hot chocolate. Ooh, that looks good. Cranberry Moscow Mule. Spiked apple cider. All of those look delicious. I wouldn't mind trying those. And you can ask it anything you'd like. You can ask it about presents for your niece and nephew, for example. Maybe you indulge a bit too much in these festive cocktails, and you could ask it to give you a basic workout routine to help you shed some kilos and build some strength after the holiday season. There we go. It'll give you all of this information. And again, it's much better than Google. It gives you the information, no ads that go along with it. Or I might summon my inner Phil Grove or Mark Horswill or Steph Becker and ask it to, say, rewrite Imagine by John Lennon to be about life as an academic. And just like that, it'll rewrite Imagine. So there you have it. Imagine by John Lennon, rewritten to be about life as an academic. And I'll leave it there, but I look forward to chatting with all of you about the implications of this tool, what it means, and what we're going to do about it. So have a happy holiday, and I'll talk to you soon. There's no countries and no religion too.